question 3. So for this one, you're going to need page 19. You're going to need the radius formula given this equation for a circle, this one. And you're also going to need to know all about this equation for a circle. So 2 different types. So there's this equation for a circle and there's this one as well. So for part A, you're given the equation for the circle. Here you go. And let's just write up here. So this equation of the circle, but you're told the radius. So we can get G and F from this formula here. Where are we? Yeah, here. So it says 2G is in front of the X and 2F is in front of the Y. So whatever number is in front of the X, we're just going to half it, and that'll be what G is. So if we come over here, we need to half minus 2, and that'll be what G is. So G is minus 1, and F is 4, because you just have to half the 8. So G is minus 1, F is 4, this is C in our formula. So here's the radius formula. The radius we're given, instead of putting minus 1 there, I'm just going to put 1, because when I square it, it just goes away anyway. And I've put 4 squared, and I've put minus k. Minus k is from there. Then I've got a square root. So I need to find out what k is. It's inside the square root, so I need to move the square root first. Move the square root by squaring. Make sure you do this bit in the calculator. Be very careful. Put this whole thing in a bracket and then square the outside. You get 75. Safer might just be 5 root 3 times another 5 root 3. But yeah, if you must square it, make sure the square is not just on that 3. Make sure it's in a bracket. Okay, 1 squared plus 4 squared is 17. So 1 plus 16 is 17. Move the 17 over, you'll get minus k. So 58 equals minus k, and then just swap the signs over basically. So k equals minus 58. Right. So this guy, again, equation of the formula. The centre is 5 minus 2. Swap the signs over. So minus 5 is 5 and plus 2 is minus 2. And that's the centre of the circle. I've done a little sketch. Tangent to the point 9 minus 4. So again, put that on the sketch. And you need to find the slope of the tangent. So slope of this line. Okay. Right. If we find the slope of the radius, then because that's perpendicular, we can find the slope of the tangent. So slope of the radius, we're going to use the slope formula, so y2 minus y1, x2 minus x1. Put that in there, it's on page 18. You get minus a half. So the slope of the tangent is the negative reciprocal of this. So it's minus that, so plus, change the sign basically, and swap that over. So 2 over 1 is 2. So hopefully, relatively easy question. C, fairly tough now, fairly tough. So I started off doing C, and I wasn't going right for quite a while, until about here. Well, I wouldn't say that, I was just doing too much work. So, at the very, very top, what we have is that the circles, both of them, touch the x and y axis. And from that then, I was doing little bits of experiments and stuff. I was like, right, for the big one, what if it was, let's say, 7 and minus 7? What would happen? And the key thing, if it was 7 and minus 7, is that the radius would be 7. So this distance would be as long as the coordinate that you choose. Okay, so if it touches both of these, the 2 coordinates need to be the same, but the y needs to be a minus because you're below the x-axis. So 7 minus 7, or 6 minus 6, or 5 minus 5, and so on. But whatever number you choose, the radius will also be that number. So the distance from there to there is your x coordinate basically, and distance from there to there is your y coordinate. So what I did was, okay, I can make myself a circle equation and then substitute 1 and minus 8 into that equation. Now I did it for the small circle and the big circle, but you only, as it turns out, only have to do it for one of the circles, and you'll get 2 answers from it. So I was going along doing double the work basically, but you don't need to. So let's go with just the big circle, the C and the minus C. So this is where we start from. So our x coordinate of C, it's minus C in here, remember, swap the sign, and our x coordinate of minus C is plus C here, and the radius squared, so C squared. So this is the thing that I'm going from. I expanded the brackets, and then I'm going to put 1 and minus 8 in. So this is a crab claw, this is x minus c, and again x minus c, and then crab claw it out. You get to this over here. And I'll let you do that. I'm confident that you can crab claw stuff. You'll get minus xc twice, so that's why I've got minus 2cx or xc, it doesn't matter which way around they are. But you're going to have xc, you have 2 of them, so there's minus 2xc. So we go from here and we say, right, what if I substitute 1 and 8? And minus 8, sorry. So 1 there for the x's, and minus 8 there for the y, and minus 8 there for the y. We get down to here. Okay, and then this is going to be a minus b, because I've got my c squared, I've got my c's, and I've got my numbers, my 64 and my 1. So combine them all together, so I've got c squared minus 18c plus 65. I also did it with the small circle and saw, look, it's exactly the same, and kicked myself because I've done too much work. Anyway, you can minus b from here, or you can factorise. For me, factorise is quicker, so I get my answer as 13 and 5. You could do exactly the same thing with the minus b, you get 13 and 5. What that means is then, this large circle is 13 minus 13, and the small circle is 5 minus 5. That's why there's 2 answers. So my small circle, I've got my 5s, 5 squared at the end, and my large circle, I've got my 13s, 13 squared at the end. Toughest question so far in this paper, I'd say.